trying to explore the use of genetic modification in the control of malaria transmitting mosquitoes. So for this, the idea is pretty simple. It's that if we could genetically modify malaria transmitting mosquitoes, we can then reduce their ability to reproduce. And if that can happen, we could then curtail the transmission of malaria because of the reduced numbers of the mosquito vectors. Malaria is transmitted by mosquitoes that are able to do this, and not all mosquitoes really do this. In Africa, we have over 800 species of mosquitoes, but of those, only 3 closely related mosquito species are the culprits for malaria transmission. So in our technology, we are targeting the major actors in the disease transmission, and here it is Anopheles gambis. So that's one of the 3 species that are responsible. So we think that if this could be targeted in a very precise way, in the way genetic modification can enable us to do, we can curb the malaria transmission. Of course, that's the big idea. So how you do this is you specifically target mosquito genes that are involved in reproduction, and you deactivate them. And then that then limits the ability of these mosquitoes to reproduce. So this has to be created. So you have to design this in the lab, and then you hope that that modified trait can be spread through the natural mosquito populations. And as it spreads, the numbers reduce. And as they reduce, then at some point, you can break the malaria transmission cycle. Now, this work is not done at once because it takes a long time. So we are doing phases of research, and it's going to take time. But at the end of the day, you have to be able to find the right modifications, and then you have to test them to make sure they are what you want and that they are efficacious, and all that is going to take a lot of time. Like I said in the presentation during the seminar, it could take up to 10 years before we find something that we say we could use for deployment, but that's in the future. But for now, what we've done today is to get the journey started. And with that, we constructed a facility called an insectary. An insectary is a laboratory where you rear mosquitoes and do experiments on them in a controlled environment. So because this has not been done, there's no precedence, we have to move cautiously. So we need all the infrastructure that will support this kind of work. And international guidelines require that for genetic modification, you need a facility that can contain them to a certain degree of containment, and that's what we built. So the event was about almost opening up a facility that expands the opportunities and capabilities of our scientists here to be able to be involved in this kind of work so that it can be carried out according to international acceptable standards. So in a nutshell, you consider this as laying the groundwork for biosafety so that we can be able to do this kind of work in an environment that's acceptable and that meets international regulations and standards. Of course, we haven't worked alone in this. During the construction of the facility, we consulted the National Biosafety Committee, we consulted the Ugandan National Science Council on Technology. These are regulatory bodies that regulate biological research. We also approached NEMA for the building. So we're working together. On the other hand, we also need to make sure that we engage. But because it's stepwise, we are also going to also engage in a stepwise fashion. So as activities increase, you're going to see more and more of us engaging different stakeholders. At the stage where we're at now, which is the beginning and baseline, we've engaged locally about the construction of these facilities. So we've asked the surrounding communities, informed them what's coming, taken their views and things like that. But the project is long. This is only the beginning, and we think that if we move cautiously and we move deliberately, we might be able to come up with a new tool that could contribute to malaria eradication. So what I also didn't say is that the partnership is broad. It's not only Uganda Virus Research Institute that's involved in this. We have other collaborating institutions. So it's a consortium. It's comprised of 14 institutions that are found in Africa, Europe, and America. And together we bring this sort of expertise. Each institution brings complementary strengths to the project. and together we hope we'll be able to find a new tool that will complement existing tools and be able to fight malaria in a manner that's cost effective, long term, and hopefully sustainable. Of course, we have tools that have helped save lots of lives, like you've heard during the presentations today. But in spite of that, malaria has remained with us. So if we want to eliminate, we need to look for additional tool to complement precedents. You have to do things in a stepwise fashion. So even creating the modified mosquito strain, we start in a stepwise fashion whereby we develop with strains that are modified, but that may not have all the traits that we want, but we want to do proof of principle. So once you do that, and you convince yourself that they're behaving in the manner that you want them to behave, and that the modification has only effected the changes that you want and nothing else, then you move to the next stage. And then the next stage then will be building the versions that you think that can do the work. Because the version that we want to use as a tool have to be able to spread that modification that we're talking about from the parents to the offsprings in a relatively short amount of time or at an increased rate. So imagine the pathway for development going from having proof of concept, you test those, you make sure they work. First, you study them under containment. Then there are questions that you cannot answer under containment, which is the insect array. Then you may need to do field releases to test for those questions, like, for example, how far the modification goes, whether the modified mosquitoes can mate competitively with the wild type ones, and even later on, questions about efficacy. Those needs, field releases. But all that is done in a stepwise manner. And even when you're designing a product, you need to know what are the ideas, trying to answer some questions that can inform, whether the mosquitoes play an important niche in the ecosystem and things like that. For them, they're not releasing. But for the releases, maybe what also didn't happen is that the first thing is not to release. You first study them under containment. So that's the work that we have to do here in Uganda, have probably a year or so, trying to understand the effect of the modifications on various biological traits. Because once you modify, you want to make sure that the modification did not affect any other trait that you did not intend to. So to be able to do that, you need to study them under containment, like in the insectary where we are going to have, and convince yourself that the profiles that were designed and that described your modification exactly hold even for your mosquitoes. Of course, you have to relate that to the unmodified mosquitoes. So that phase will first have to be done. And if you are satisfied with that kind of result, then there will be questions that cannot be answered with just only containment. Then you want to simulate a more realistic environment, and that's questions, for example, like, are they competitively mating, for example, with the wild type 1? Because the modification has to be spread through mating so that the progeny that are born have it, and then they mate, they spread. So if they're not competitively mating with the wild ones, then your technology has flopped. It's not even going to get the job done. So it means we've started the work. So you do baseline studies, but that's field collections to study the local mosquito populations so that you can be able to design a tool that's adapted to the local environments. And then we have built the infrastructure that we needed. It was not there before. The research is regulated because all biological research, especially research that had to do with modification, requires approval from regulatory bodies. So UVRI has a safety committee and an institutional review committee that looks at the research. But then again, when we start doing the modification work, because we've just put up the facility now, when that work starts, we will need an institutional biosafety committee that's based at UVRI, and we'll use all the UVRI infrastructure to get this work going. So it's lots of ways. It's difficult to separate the project from no one single tool that can get the job done. So it has to be used as a combination with other tools. So we are not envisaging that this one sole technology will be the one that will get the job done. So we'll have to continue doing what we're doing, but then also add this other additional tool to help with some of the challenges that we're facing with the current tools. If you look around, our mainstay tools now are nets, bed nets, insecticide-treated bed nets, and also insecticide residual spraying. So if you look at those, they're facing important challenges. This has to do with the evolving of insecticide resistance. So the mosquitoes are becoming resistant, so they're not as dying as they should be. But also sometimes it's people are not using nets, or sometimes it's the mosquitoes themselves changing the time that they bite, so that they start biting you at other times, not when you're in the net. Already those are gaps. If you look at using drugs to treat the disease, again, there's the issue of drug resistance. So this tool is designed to complement, not really replace. And no one thinks that at the moment, with the toolkits that we have, we can reach eradication, if it's eradication that we want. We still need new tools, and this will come in to support that.